As Lane said, he's been a supporter from the very early beginning of Urbit, the project I'm here for today. Many more other people around that have been on Urbit since the early days. Before I start, I really want to thank Erica for this amazing conference. I know what it takes to pull off a conference like this, and I haven't been at many conferences that are this elegant and smooth. So thank you a lot for that, and for our entire team. Now, how tired is everybody? Are you tired? One guy, yes. Okay. Well, this is going to be a very different presentation from what you have had. I'm not going to talk about a lot of technical specifics. I'm going to present a vision. And it starts with the question, are we ready for a new computing paradigm? We are, and I hope you guys are as well. So let's dig into what the legacy of computing actually is. The legacy of computing started with a dream of actual computation on machines instead of brains in the beginning of the last century. By the 50s and 70s, we had these mainframes that filled up an entire room, needed 30 to 40 people to man one of these mainframes and do computation. Very heavy on manpower and very low if you compare it to today's computing standards in computing output. Eventually, towards the mid 70s and about the mid 80s, we started to get this device, which a lot of people in the room probably still used, the huge desktop computer, but now you have personal computing, that one person could use that computer individually. Really big stepping stone from these big mainframes that were only suitable for big corporations. Now everybody had their own productivity tool, creativity tool on their kitchen table. Really big advancements in computer science. Now the big question was when we had these personal computers, how are we going to connect them with each other? And connecting these is not a simple task. Connecting these actually has a lot of questions how you should do that, and it had a certain result. But if you look back and these days, what we were thinking about is okay, email, for example, is a service we still use nowadays, right? It was built on principles of let's have peer-to-peer email, have all our services be just connections between these personal computers. What we ended up with was this. In the early zeros, when networking technology became really serious, late 90s towards around today, we started to see that this hierarchical infrastructure started to emerge. We all are familiar with the companies that are at the top, Apple, Google, AWS, Meta. And we all hook into their servers with our personal devices. That's how most of us compute nowadays. And even while we're at a crypto conferences, I know that everybody in this room uses one of these services, probably 24/7. Now, another representation of this is actually a model like this. We basically hook into these big server farms, which are nothing more than big mainframes administered by thousands of people. And now we have not one personal device, but we have multiple personal devices that we hook into this big mainframe too. Now the thing here is that mainframe has thousands of sysadmins, and we have 3, 4 devices that we also all have to maintain, administer, update, and whatnot. Right? This is not really an ideal situation, I would say. So how did we end up here? There are a few considerations that at least we believe have us end up in here. One of the first things is that the computing stack, how it was built, was never built to be networked, right? It didn't have a lot of affordances in order to provide good networking technology. Didn't have any authentication, didn't have any sense of identity, and it still doesn't, right? So that incentivizes a world in which we have centralized network technology run by a bunch of large corporations. Another point is maintenance, right? I really love this meme, which says basically a project some random person in Nebraska has been thanklessly maintaining, and it's basically holding this entire stack together. I think this refers to to Linux. The computing stack wasn't built to be easy to maintain. Definitely not to be able to be maintained by one person. That's why we don't run email servers ourselves, because we wouldn't be able to in any way to maintain it all the time and defend it towards all kinds of system attacks. It's not really what we were promised. And when I say promised, I refer specifically to email again, right? Like, we were not promised this kind of email. We were promised peer-to-peer connections first in universities and then on a personal level. And so who promised us this? The people that promised us that are actually the founding fathers of crypto. It's a cypherpunk movement that was started in the late 80s, beginning 90s. Behind me are the three guys, Eric Hughes, John Gilmore, and Timothy May, that started the cypherpunk movement. Oh, and by the way, for the young people in the room that don't know what the cypherpunk movement is, it's a bunch of boomers with a mailing list. I hope that explains it. So the cypherpunk movement thought that we needed to build our digital infrastructure around a bunch of principles in order to get a free and open digital world. Everything needed to have privacy built in. It needed to be completely secure through the means of cryptography in order for us to gain digital freedom and an open, free society. And, preaching to the choir, it needed to be completely decentralized. Now, as you might have noticed already, this is quite familiar with what we all have been trying to do here, right? Crypto checks all of these boxes. And that's not a mistake, because the first manifesto that they wrote, the first 50% of it was basically about a digital currency that lived up to these standards. That's why I called them the founding fathers of crypto and blockchain. Now, what crypto has done is basically fought this hierarchy off. Fought the hierarchy of centralized banking and made banking a tool that's public and freely available for everybody on the globe. Completely decentralized, private, and you own every coin cryptographically. The other Goliath in the room that we are trying to tackle is this one. The big tech oligopoly is something that we need to bring down in order to create this open, resilient, censorship-free society that we were promised. And what I'm trying to talk to you guys today here about is like how crypto and what we are trying to do are built on, that they are built on the same fundamentals, and we need to make sure that we team up. Bitcoin and Ethereum have laid the groundworks for building an open and free society. What Urbit is trying to do is like replace all of computation and build it out on a new stack that's completely decentralized, completely private, and cryptographically owned, entirely secure. I would like a world that kind of looks like this. We all have different devices that we run ourselves, peer-to-peer. We have financial nodes that we interact with in order to prove things on-chain, for things that require global consensus. And for things that require local consensus, we just interact with each other. If I send you a message or a message to my mom, I don't really require global consensus on whether that message was actually sent. But if you can verify that it was sent by me to you, then we have local consensus, and that's probably enough for a lot of the computational tasks. I'm calling for a cypherpunk renaissance. And that ties in with a great paper, which I think is, no, there it is, which is written by Vitalik, makes Ethereum cypherpunk again. Really, really great blog post that you should all read, where he goes back to like early writings from Gavin and himself about like how Ethereum should become more cypherpunk. What he means by that is basically that Ethereum has laid out the groundworks in order for a decentralized financial world, but we need more decentralization tools in order to make this cypherpunk dream come true. And I'm presenting that Urbit is that technology that we need in combination with crypto to get there. What Urbit has done is we have reimagined the computing stack from scratch. And when I say that, I mean that. from scratch, bottom to top, reinvented the entire thing. We believe that this was necessary because our computers that we use nowadays were never built to be networked, were never built to hold currency. They were basically they're not built for what a modern day computer requires to have in its fundamentals. Let me give you a really brief flight through what Urbit offers today. The Urbit operating system, or how we like to call it, Arvo, is a self-updating, full-stack deterministic computing stack that's private by default. You get rid of all the sysadmin. We have solved the dependency hell. We have a statically typed functional programming language on top. We have portable snapshots. If you go from one device to the other, you can boot the system and everything is as you left it. We have a revision-controlled file system, and we have a persistent identity per Urbit node that we proved on Ethereum as an ERC 721. We're actually one of the very early adoptions of NFTs, and actually did something useful with it by integrating it into our PKI in the early days of Ethereum. Also good to know the founding ideas of Urbit go back way before Bitcoin even was realized. The first writings about Urbit have been written up in 2001, if I recall correctly, and it's been more seriously it has been more seriously sought after in the last 10 years. We also rebuilt, because we really like rebuilding things from scratch, we rebuilt AIMS, which is our standardized networking protocol. And you need to have that if you're trying to build a peer-to-peer system. You need to build a networking protocol that's completely peer-to-peer, always. Has full end-to-end encryption, is Sybil resistant, and every packet is signed by your identity. Now, it also has a bunch of features like built-in NAT traversal, it's idempotent, so one-time message delivery, and a bunch of other cool things. Now, basically, every packet that you send, whether it's a message, whether it's an application packet, it doesn't matter. It's signed by the identity, encrypted, sent to the other person, verified that it's from that identity, decrypted, and now you have the actual data. And that's all along. So it doesn't matter what you build on Urbit, every application, every time you use networking, this will be enforced. Now, Urbit, in and of itself, has really good qualities to build decentralized applications on, because anything that you build on Urbit, as you might guess, is per definition decentralized in its networking stack. So Urbit nowadays for crypto dApp developers offers a lot of affordances that you don't have if you use any other system, right? You don't have to care about identity management because you have a persistent identity, and you can always be assured that it's that identity that's connecting to you. It has a social graph built in the base layer, so network effects are a one-time thing, and you have them for life. You have general purpose HTTP servers. You can serve stuff to the regular web and have people that are not on Urbit just enjoy it as much as others. It's always, all the data is fully in control and owned by the user. It has peer-to-peer app distribution built in. Yeah, a lot of things. And we have improved our storage by, I think, 4 orders of magnitude up to 64 terabyte pretty soon. And the same has happened to our networking stack, which is going to be up to 1 gigabit. So it's an actual full-fledged operating system that you can use today to build your applications on. And Urbit is designed to last forever. And we really mean that. We have been very deliberate in designing this kernel. The kernel is about 30,000 lines of code, which is extremely tiny for an actual kernel. Now, how we have done this is one of the quirky things. We have designed something we call Kelvin versioning, which I always like to talk about because it's a really fun and differentiating way of how to do versioning in any operating system. It's a descending versioning system where you go from 500 to 0. We are, since this week, on version 411. Once we end up at 0, the computer is frozen forever. It's never upgradable again. And the idea behind this, it might be frightening for the developers in the room, but that's exactly the purpose of it. What we want to create is a world in which you build software that's going to last. You need to make software that becomes more efficient over time and is not another patch on patch on patch. It's more about reducing the amount of code than adding more code to the system. And that is why we have designed it like this. And it's real. There have been over 180 apps been built on Urbit, all fully decentralized applications that work and you can use. We've shipped one today ourselves as well. We have a pretty big developer community that's very excited to build more applications, build out integrations. We've built a great application with Near, actually, that we've updated this week as well, which allows you to interact with Near Boss components directly from within Urbit, or lets you interact from Boss components directly back into Urbit. We're working on a lot of hosted front ends idea for already existing dApp applications in which you can host your front end on Urbit, and now your entire decentralized application actually becomes decentralized. And there's a fun use case of a company on Urbit as well, because there are a bunch of different companies already on Urbit. To the right, you see Tlon, which is one of the founding companies of Urbit. They built a complete social network that's fully peer-to-peer, kind of Discord-like. You can try it out today. To the left is one of our hardware companies, KryptoPlanet. They built these very cute little boxes that you can just plug and play, and you have your Urbit running within minutes at home. And they offer also a bunch of services like running your own LLM within the box, and they're going to offer more node services that hook into your Urbit straight away. Another company is Red Horizon, which is a product by Chorus One. Brian Crane, who was talking here earlier, is a big Urbit fan as well. He is part of the Urbit Foundation's board. They do hosting, so if you want a one-click solution to get onboarded onto Urbit, they will host your ship for you, but you can take it whenever you want. Alphabet is a really cool company that's focused on crypto betting markets and prediction markets. What they do is they interact with the smart contract, but because the entire application runs on your private server, what happens is the legal risk is mitigated because now the entire application is run by the user. So now there is actually, in the cypherpunk world that we stand for, you actually have the possibilities to run and own all the software from front end to back end and the interaction with smart contract. What else have we got? Oh, Zorp. Zorp is an insane project. They built a zero-knowledge virtual machine and a ZK prover that proves our machine code language called NOC. This is its definition. It only has 12 opcodes, and it actually fits on a T-shirt. So it's really tiny. It's probably the most tiny machine language that you've ever seen. And the interesting thing is, so another fun fact is the hardware company I was just showing, they actually built and designed a chip to run NOC on bare metal, and they have succeeded 2 weeks ago to run NOC on bare metal, and they're now designing a prototype chip to build actual Urbit chips in the long run. So what Zorp does is they prove this machine code language in their ZK provers, but because every Urbit application compiles down to this language, you can ZK prove entire applications on Urbit, which is going to be extremely difficult on any other stack. But here it's all one machine code language in the backend, so you can prove entire apps. Can't tell much more how excited I am about it, because the ZK space is extremely competitive from what I've seen. Those are our companies, and they're building great products. And you can join Urbit today by scanning this QR code, or go to urbit.org/start. Get on with one of our hosting providers, or buy a machine, download it on your own machine, set up a cloud instance. You can run it wherever you want, and yeah, go check it out. It's a great universe, extremely intelligent people out there that are eager to build the applications for tomorrow. And also feel free to reach out to me. Follow us on socials, on Twitter and Instagram at Urbit. Go to our docs, roadmaps if you're more technically inclined, and do feel free to reach out to me with any questions. Thank you very much, and I'm happy if we can all together make the cypherpunk world a reality. Thank you.